Honestly, I increase the number of strips, the number of gaps will increase beautifully. The number of gaps will increase when the number of gaps increases, meaning each gap will be responsible for its own specific object, right? All right, reducing. The thickness gives you the opportunity to increase the number of gaps correctly. I liken it to you like this. The filter, the holes in this filter, the more numerous and smaller they are, the better the resolution you will get. It will give you a better resolution, unlike when they are large and few in number.
When they are numerous in number and small.
There are many of them, and their number is large, meaning there are many, and the holes themselves are nice or something like that. So, who gives you a better resolution? Is it the one with many small holes? Or let's assume it has a large number, but the holes are big? It's as if you have a small object. This small object that exists is the small one that is present. It's as if there is any other signal coming from adjacent devices, I have the LED that will block it. And this part seems to be dedicated only to this small size. This small part should have a high resolution because the number of gaps I have is increased, right? If these gaps are 1 and the thickness is increased, it means that I have the same shape, but you have increased the thickness. So, if I increase the number of gaps, the number of my gaps remains the same, and if I increase the thickness, you might say that makes sense. But I increase the gap, and just as there is a probability that photons hit the strips, there is also another probability that says it will increase what? The discrimination that occurs when a photon comes from a specific object while another photon comes from an adjacent object. I won't take it, meaning that having many strips prevents scattered photons coming from neighboring objects from entering the same hole in the same place. So, having many strips increases the chances of photons reaching their destination. It's as if you improve the resolution, but you will need to increase what? Increase the dose. May God open your way to address the problem you just mentioned, which is the idea that there are many strips, so you will significantly remove part of these photons. Therefore, I need to increase the dose to balance the problem.
The question about high-frequency grids includes what I am involved in with the cross grid, which is in the X and the parent grid. Is this one thing or another? I am talking about the high-frequency grid in relation to focus, as focus is what has developed. The most common usage, especially with digital imaging. Why did I use this cross?
The problem with the cruise is that it needs to identify the issue, and you need to perform problem identification. Why? Because you are doing problem identification in both 1D and 2D. If there is any issue in identifying the problem, you will have a problem with the story we will discuss shortly. The story is that you will perform absorption through the strips that are present, and this will affect image quality and give you artifacts if there is misalignment or mispositioning. The most commonly used method is considered refocused. There is something called a virtual and scatter grid, which is identified when it is burned. This topic exists in phones and is not a topic related to hardware. It is a topic that exists in phones and not in hardware, and it is not a topic related to hardware. This topic is prevalent in mobile devices, particularly smartphones, and is distinct from hardware-related topics. It is a subject that is consistently found in mobile phones, separate from hardware discussions, and it does not pertain to hardware. The idea of calibration is that you have a detector, and each detector is connected to a pixel that has a photomultiplier tube, and the signal is taken and converted into an electronic signal, it is expected that all pixels or all detectors should give you the same signal if there is nothing in the field of view. For example, if I am exposing in air, I should check if there is something that will stabilize it. The effect of each detector or each pixel should ideally be the same, and the effect of all the components responsible for the signal should also be the same. Sometimes a problem occurs. Why? Because there was no effect. Which means what? It means adjustment. You are preparing the gain or the signal value that the pixel receives. What does that mean? It means you say, I will image without air and see if each pixel received the same signal or if there is a difference. So what will I benefit from this? You will benefit from having an image. As a reference image, knowing what the value of each pixel should be and how it differs from its neighboring pixel, and you will have an accepted range. So how does this benefit me? It benefits you in that when you come to image any patient and there is a specific defective pixel next to another pixel, it can correct it using the neighboring pixel, meaning a healthy pixel, and a pixel that has a defect for any reason. So this deals with the neighboring pixel, not every pixel of course, meaning each group of pixels next to each other can work on it. So what does it do? It takes, for example, the value from the neighboring pixel to make a correction for itself. This helps in the calibration, which works on the same idea and understanding. If I could understand a different concept, for example, a phantom, this phantom consists of layers made from different materials. And I start to measure and see if the sector coming from this scan matches each scan I have in a detailed manner. Each scan starts to give me a certain sector, and as the thickness increases, the sector you have also increases, and thoroughly. You start to work on it, as it is available to reduce the sector and make it what it is in various ways. So I will calculate how much for this sector through calculations and experiments on your machine, and I start to work on it and comprehensively. If it is operational, it selects what is available, and based on that, it starts to be processed in a systematic approach. This topic is, of course, already present and meticulously. This is not just for all devices, but you should have the same effect for the grid. However, you must choose the patient value before the operation, and there is a program that simulates the patient value and the sector before the operation. There is a factor that works on the primary sector, which is referred to as the sector to primary ratio. Where is this? He creates a ratio between the scatter and primary radiation and observes how thickness affects this relationship. Then he updates this, and through the software, he begins to process and improve the scatter. Of course, this is much better to avoid the issue of anti-scatter grid artifacts. There are problems that you can completely do without. Of course, not all devices have this. For example, Fujifilm has implemented this feature, but it's optional. This means that, of course, these features come at a cost, so they won't provide such an option for free. However, this does address the issue of artifacts that exist. For example, the grid ratio and its relationship with increasing values. As we mentioned, 8 is the one I use, and 16 is used in chess cases. Of course, the increase or increment is in milliampere seconds and kV. Now, there are some things, for example, something called kink artifact. I don't know if you can see it or not. We are seeing this egg-shaped point, which is one of the artifacts that can appear, called kink artifact, resulting from negligence in cleaning the imaging plate. This means that the imaging plate was not cleaned properly, leading to some residues and dust that can cause these artifacts and may create misdiagnosis in this diagnostic process, referred to as kink artifact. There is also something called the light bulb effect. The light bulb effect causes a phenomenon known as darkening in certain regions, which appear in this way. Here you find that the level of darkening is less than the neighboring regions around it. This is due to what? It is because sometimes the energy or kV is increased, especially with larger patient sizes, resulting in higher penetration power. There will be an interaction between the energy of the X-ray photon and the table itself, which can increase the scattered radiation. That may occur and enhance the exposure, thus affecting the signal that reaches the imaging plate by creating hypodense areas in certain spots. This is often seen with patients due to its large size, and I have to increase the kV specifically because of the penetration power, and it can involve Compton scattering, as we mentioned earlier, causing the artifact known as the light bulb effect. We addressed the patient artifact and the acquisition, and in image processing, there are aspects related to CR, because it is one of the areas with many associated problems. When I perform reading for my imaging plate, as we mentioned before, the idea is that when I place my cassette, it starts to open, and the imaging plate begins to come out and move onto the roller. As it moves, it gets exposed to the laser beam, which starts to release electrons from its active centers, and the trap site begins to drop to the finance instead of emitting the light photons that I start to receive. So, the roller might not be clean and needs to be periodically cleaned by the engineer. The mechanical motion of the roller must be correct and should move a distance every second. Why? To ensure that the exposure to the laser is uniform, so that one part does not get exposed to the laser more than another. The part that is exposed to the laser more will emit light photons at a higher rate than the other, which will affect the resulting image. The roll cleaning must be proper. 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 Like this, here is a white spot. I don't know if it definitely appears visible for you or not. Here are dots. This is indeed a result of dust present on the imaging plate itself. The cleaning should be done at least once a week with alcohol and left for about 10 minutes to dry. This cleaning should be done if no tissue or anything that could leave vapors is used, as it can create artifacts during imaging and lead to misdiagnosis. For example, the roller itself has a problem. It moves slowly in a certain area and moves at its normal speed in another area. The part that moves slowly is exposed to a high laser beam, so the light intensity is high, which results in inhomogeneity in the image. So here is the image that is present, okay? This is a radiographic image. This artifact that we see is a result of a necessity that occurred for the imaging plate. The imaging plate moves on the roller and experiences stress. This stress may cause a necessity. This necessity may lead to an artifact. Therefore, the roller must be maintained regularly to address the parts affected by the artifacts we see, which can lead to misdiagnosis. There are obstacles or radio obstacles present, and a condition like this is caused by granuloma. It is not like this because there is a method for the imaging plate, which should be changed approximately every 5 years. Here, for example, on the roller, do you see this horizontal line, the white one? I don't know if you can indeed see it, but this is indeed a result of dust on the roller, and it has created this artifact in this area.
Dr. Islam, the previous image, which is about the imaging, implements a set of the United group. How can I determine, or how can I suspect that there is a problem with the engine? Honestly, doctor, you will have a lot of things. First, are the machines doing the periodic maintenance correctly or not? Did you inform the patient of the same history?
Are some of the existing walking patterns effective? Do they work at the level of balance correctly or not? Are you talking about the level of existence? There are things that might relate to the clinical part, meaning your clinical section, and surely you will be the one to determine whether you will find this or not. First, the machine itself must be, it has to be, this has to be done and reviewed. Are the rollers being cleaned or not? There is nothing you can say about the image based on my experience. I cannot tell you, for example, that it looks like this or that. However, if you are someone with expertise or knowledge, you would definitely understand the images 100 times better than I do. If there is something you can tell us about this image, it is that I brought it before a long time ago, and it was discussing this image in relation to blood results. If there is something you can tell us from the image that is not possible, I don't know. If you have this image, I would be grateful.
It is possible that there may be an update or news that might be available on more than one case or situation.
We will know more than one case. This is true. If there is a decision with me in more than one case, there is a problem with the same issue. We know that most imaging processing artifacts are more common with CR, of course, because reading is not dependent on the operator. There are artifacts that occur. And naturally, as you might expect, in digital radiography, and as you know, I see that most of the artifacts I mentioned are related to the car. Sure, doctor. As you know, computed radiography, CR, is considered the digital upgrade that replaces the traditional CR. In the field of medical imaging, however, I still believe there are people who are still developing films. Here, we have the plate reader artifact. Here, for example, as I mentioned, there is also the path of the light guide, or the light that reaches the photodiode, or I have the receiver or the collecting device that collects the light intensity. There is a problem, and this line starts to appear in this way, indicating that there is an issue or that my light intensity did not reach me correctly, which affected the signal and resulted in the artifacts present. These are all examples of artifacts found in images, and this is the same topic as the phone. The part related to the scattered component contains a LED foil made from it. The lead foil is supposed to prevent scattered radiation, but this scattered radiation can cause black lines during the back of the cassette. This means that backscattering can occur, or there can be another interaction between the scattered radiation and the LED, leading to the same issues. Some of the scattered photons can create some of the black lines that appear, and in this case, I don't know if you can see it or not, I can zoom in. You might say, for example, that there is a fracture or something in this area, and this does not become real here if you do not have proper collimation. If the collimator is incorrect in part of your collimation, it is not accurate, or we might call this a ghost image, meaning that there was a part that was captured or not captured completely. Sometimes after a process, it starts to produce a certain intensity that releases all these electrons and returns them if there is something left. And it goes back to how it was. If this does not happen, the same story applies, and you start to see that there is something, or that it appears in this way. This is part of the images that are also present here. And God willing, you will find them very helpful. I tried to elaborate on the topic of artifacts so that it is close to the diagnostic subject, as I believe it may benefit you greatly. We are supposed to talk about mammography. Shall we take a 10-minute break and return? To separate the topic from the subject, a 10-minute break sounds good. Thank you.